how do we do this? How do we do it with this information? So, ta-da, here's how we're going to do it. What if instead of, with the law of sines, we always had an angle and a side across from it? Okay, we always had an angle and a side across from it. What if we don't have an angle and a side across from it? So, for example, we have two sides and the angle in between those two sides. So, for example, what if we have sides B and C and angle A? We do not have enough information to use the law of sines, because the law of sines, we have to have at least one angle and its corresponding side. Or what if we have all three sides and we've got to find the angles? Well, that's where what we call the law of cosines comes into play. Now, I showed you where the law of sines comes from. I can show you where the law of cosines comes from if you really want me to. But it's a little bit more complicated than the law of sines. The law of sines is a little bit more straightforward. This is related to the Pythagorean theorem, because the first part of it here looks like the Pythagorean theorem. A, B, and C are just in different orders. And then the second part has to do with the fact that, well, we don't really have a full right triangle here, so we kind of take that part away. But anyways, this is the law of cosines. You need to memorize it. Just like with the law of sines, we can use any order that we need to here. Okay, I've got the other two versions of it. They're exactly the same thing. Okay, it really just depends on which angle you're solving for, or which side you're solving for, what information you're given. Okay, it's the exact same thing. It's just rearranging variables. Okay, so here's what I remember when I'm trying to remember the law of cosines. I'm always going to have one side over here by itself. Whatever side is over here, that's the angle that's in the cosine. Okay, so if we're solving for side A, then we better have an angle A in the cosine. The other two sides are going to be squared, just like the Pythagorean theorem, and they're the ones that would multiply by 2. Okay, they're the ones that would multiply by 2. So it's the same form in all three of those. All right, questions about just the formula? We can use it to solve for a side, and we can use it to solve for an angle. Solving for a side, pretty straightforward. Solving for an angle, we got to be careful with some things. Okay, so we're going to start with solving for one of the sides. All right, anybody need more time to write anything down? Good. All right, so we're going to solve these same things. We're still talking about scaling triangles. They're not right triangles. We're going to solve them using the law of cosines. The good news is, once you do the law of cosines once, you've got enough information that you can then just use the law of sines. You don't have to use that formula over and over and over again like we did with the law of sines. We had to use it twice. All right, so let's look at this case. We are told that side B is 9 meters, side C is 12 meters, and angle A is 25 degrees. We do not have what we need for the law of sines, because we don't have any of the corresponding angles and sides. So B is 9 meters. I'm just going to label the triangle I've got here. C is 12 meters. Angle A is 25 degrees. So I'm going to use that first form of the law of cosines because I have angle A. So let me just write it in general. I know you have it right there on your paper, but I'm going to rewrite it. A squared equals B squared plus C squared minus 2BC times the cosine of A. Now I'm going to plug in the specifics. I don't know side A. Side B is 9. Side C is 12 minus 2 times B is 9, C is 12, times the cosine of 25 degrees. So this is why this one is so easy. You literally just have to type all that stuff in. Don't try and chunk it up in pieces. Just type it in all at one time. 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. And my calculator is not in degree mode. Okay. Excuse me. Okay, now, is that side A? No, that is A squared. Okay, so we do have one more step. We need to take the square root of that number. Do me a favor and do this. Second square root, second negative. Don't put the rounded one in there. Just keep the exact answer, 5.407 meters for side A. Okay, I'm going to round it to the nearest tenth when I put it on the triangle just to save me some space. Okay, so we're supposed to solve the triangle. So we now have all of our sides. We're missing two angles. But the good news is, as I mentioned before, now we have enough information, we can use the law of sines. Sine of 25 degrees over, now we have side A, is equal to, my suggestion is when we are solving for this, solve for the bigger angle. Okay, solve for the bigger angle first. Sine of C over 12. Cross multiply and divide. So 12 sine of 25 degrees divided by 5.4 is equal to the sine of C. 12 sine 25 over 5.4. What do we have to do after that? Inverse sine. That is not our answer. We do not have a side length of 0.9. That does not make sense. Or an angle of 0.9. Okay. We get C is approximately 69.9 degrees, which does make sense so far because it's bigger than 25. It's supposed to be bigger than 25. Let's do 180 minus that, minus 25. And we get 85. Okay, now, is there anything wrong with this? Is there anything wrong? Yes, what is wrong? The biggest side is supposed to be across from the biggest angle. So, a little thing happened with solving for C. There were apparently two possibilities for C, and we got the wrong one. So, we got to back up and punt, okay? So that was not correct. Let's solve for the other angle first. Let's solve for the sine of B. That would be over 9. Okay, so 9 sine of 25 degrees divided by 5.4 is equal to the sine of B. We get 44.778 degrees for B. 180 minus that, minus 25. 110.22. Does that work? Yes, that will work. Because now we have the biggest angle across from the biggest side, smallest angle across from the smallest side, and the one in the middle. Okay, so you got to look out for things like that. That's why I've been training you for that since the very beginning. Okay, since the very beginning. So instead of starting with the bigger side when you do the law of sines, start with the smaller side. Okay. So law of sines, if you have a choice, I'd put this note somewhere in my notes. Law of sines. Trying to think of what to say. Law of sines for two sides. Start with smaller side. Okay, so law of sines, and you have a choice between two sides, start with the smaller side. that will more than likely lead you in the right direction instead of starting with a bigger one. Okay, questions? Okay, let's do another one. Let's do one where we have 3 sides. Okay, let's go where we're given all 3 sides, so we have to find all 3 angles. So if A is 8 feet, side B is 19 feet, and side C is 14 feet, we want to solve for our angles. This is the opposite, okay? Law of sines, you want to start with the smallest. Sines, smallest. SS, sines, smallest. Cosine, if you have a choice, you want to start with the biggest angle, okay? Law of cosines, you want to start with the biggest angle. So we're going to start by solving for angle B. So that means we need to use this version of the law of cosines. B squared is equal to B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. All right, let's plug in our specifics. 19 squared is equal to 18 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. Now, this one we do need to chunk up more to solve. You cannot just type all that stuff in except for the cosine. You're not going to get the right answer, okay? So let's find out 19 squared. We'll start with the left side here. 19 squared is 361. I will go ahead and add the 8 squared and the 14 squared. We can go ahead and put that part together. 260. We need to multiply the 2 times 8 times 14. 224 times the cosine of B. Now, most times when you see the law of cosines written, you won't actually see them put that times symbol in there because it's just understood if you have 2AC cosine B, that is multiplication there. I put it there because I think it helps emphasize to you guys that we're multiplying these 2 terms right here. I cannot subtract 260 minus 224. I repeat, you cannot combine the 260 minus 224 because the 224 is attached to the cosine of B. So to solve this, if you do that, it's not going to come out right, okay? And somebody, I know, will do it anyways. Okay, so to solve this, we start by subtracting the 260. So we get what? 101 is equal to negative 224 cosine of B. Then how do we get? Good. Divide by the negative 224. And then we're going to take the inverse cosine. So I'm just going to put that into my calculator at one time, okay, instead of having to divide it and then do the inverse cosine. Okay, inverse cosine of 101 divided by negative 224. That gives us 116.8 degrees approximately for angle B. Now, once again, the good news is you only have to do the law of cosines once because now we have enough information. We have a side and the angle that corresponds with it. So we can use the law of sines. Now, we can't avoid using something that we calculated. I tried to encourage you to avoid doing that when we did the law of sines. You have to use it here unless you just want to do the law of cosines over and over again, which I don't think you want to do. Then what did we say our rule with law of sines was? We have 2 angles that we have to solve for. Start with a smaller one. Okay, so sine of A over 8. Sine of A over 8. Cross multiply, divide. Do the inverse. We get angle A is approximately 58.947 degrees. 180 minus that, minus 116.8, leaves us with a really tiny little angle, 4.253. Nope, that's wrong one. Wait, what did I do again?
You didn't close the phone.
Yep. Thank you. I know. This is my second mistake today. Off my game. Okay, there we go. That looks a little bit better. See, that's why y'all should always be calculating it when I am, because I'm not perfect. 22.075. That sounds better. 180 minus that, minus 116.8. That's better. Okay, so angle A should be our smallest. It is. Angle C is the one in the middle. Side C is the one in the middle. That's a 41. Doesn't really look like one, but that's a 41. 41.12. Okay. Questions? Okay, so I want you to practice.